Hi everyone, welcome to my Edexcel GCSE Mathematics June 2011 paper. We're looking at the non-calculator exam. We're going to work through it. Should we see how quick we can do this paper and how well we can do? Question 1. Here's a list of ingredients for making 10 flapjacks, okay? So you know how many to make, how much of each thing you need for 10. If you want 15, that is 10 add 5. 5 is half of 10, so it's 1.5 lots of it. Okay, so all we're going to do is times each ingredient by 1.5. So our ingredients were 80, 60, 30, 36. We're going to find half of them and add them on to what it was before. So half is 40, 30, 15, 18. Add them together. So 120, 90, 45. This one you might want to do a column method to get 54. And you're done. 3 marks. Okay. Moving on. Question 2. Harriet reads 8 books. For each book, she records a number of pages, the time she's taken to read each page. The scatter graph shows the information about her results. Okay. Describe the relationship between the number of pages in the book and time it takes for Harriet. Okay. So as the number of pages increases, the time it takes her to read increases. It takes her to read it increases. It makes sense. If you see a big, thick book in front of you, it's going to take you longer than a smaller book. Harriet reads another book. The book has 150 pages. Estimate the time it's going to take her to read it. Okay, so let's go back to our graph and let's think about how many pages, 150 pages here, and we want to estimate whereabouts the cross would be. The best way to do this is to do a little line of best fit. Now what I've just realized is this isn't very realistic, because if your book has got 0 pages, it takes you 0 time to read it. Okay, so you might want to think about what happens at 0. Try and put it through the middle of all your points. So, from 150 pages, let's go up, let's go across, and now let's think about the scale. Here's 7, it's going up by 0.2 each time, 7.2, 7.4, 7.6. So 7.6 hours. Does it want it in minutes and hours? No, it just wants hours. So 7.6 hours. I think we'll get you the marks there. It's not asked you to convert. Okay. Question 3. Angles question. ABC is parallel. ARB is parallel to DQC. PQRS is a straight line. Angle SRB equals 55 degrees, as we can see. Find the size of the angle marked X. Well, what happens is when you've got parallel lines, this angle slides along, look. Okay, and as long as you make the same angle here, it's going to be the same answer of 55 degrees. Give the reason for your answer. Well, these are called corresponding angles, and you get them from an F shape. Okay, so corresponding angles. Okay, clear ink. Question 4. Work out an estimate. For an estimate, you want to make your life as easy as possible. Okay, so you want to change these 3 numbers. You don't want to do 7.19 times 19.7 over 0.46 in your head. It would be much easier to change 7.19 to 7, 19.7 to 20, and 0.46 to 0.5, a half. Okay, 7 times 20, 7 times 2 is 14, add the 0 on, divided by a half. Now, do not just half the number. If you wanted to half the number, it would be 140 times a half, which is 140 lots of a half. You want to know how many halves go into 140. If you've got a full cake, that's 2 halves going into it. Okay? If you've got 2 full cakes, then that's 4 halves. So can you notice that 1 times it by 2, 2 times it by 2. So actually divide by a half is the same as times by 2. So you're actually going to double 140, get your answer of 280. What we've done here with the rounding is we've actually rounded to one significant figure in each case. Okay? That's how best way to estimate. Question 5, we've got a formula that h equals 5 times by t squared plus 2. Well, it tells us what t is. T is minus 2. So let's put minus 2 into our equation. Squared means times by itself. Minus 2 times minus 2 gives you 4, because a minus times a minus is a plus. So you're actually having 5 times 4 plus 2. 5 times 4 is 20, add 2 is 22. Work out the value of t when h is 47. So this time you're putting this into your formula, h equals 5t squared plus 2. And it's the h that we know about. The h is 47. So we've got an equation to solve. We want t on its own. Take 2 from both sides. 45 equals 5t squared. Divide by 5 on both sides. Okay, and we get 9 equals t squared. Now, if this was an A-level question, it would say work out the values. It's GCSE. It's just said work out a value. There's 2 values that work, plus or minus 3. We get that by square rooting both sides. It's just ask for 1, so we can think, well, 3 times 3 is 9. That's one answer. N is an integer. That means a whole number between minus 1 and 4. So 0, 1, 2, 3. Do we include minus 1? Do we include 4? Look at the signs, and you're looking for equals. Can you see that it's equals here? That means you include minus 1. There's none there, so you don't include 4. So we write down these numbers here. Minus 1, 0, 1, 2, 3. Question 6. Each exterior angle of a regular polygon is 30 degrees. Don't worry about polygon too much. Many-sided shape. Okay? Now ours is a regular polygon, which means all the angles and all the lengths are the same. Our question is, how many sides has this mystery shape got? So let's just draw a bit of it, wherever it is. The exterior angle here is 30 degrees. Now, we do not know what happens here. Okay, we don't know how many sides. I've done a video on exterior angles with starring this imaginary ant called Auntie the Ant. And it tells you that if you go around a shape, any shape, you've actually, or anything in real life really, if you get back to where you've started from, you've turned 360 degrees. Okay? And all these angles are going to be the same. They're all going to be 30 because we're told that in the question it's a regular polygon, they're all the same. So we want to do 360 divided by 30. How many 3's go into 36? Well, it's 12. 12 times 3 is 36. Okay, and the 0 makes no difference because you add it here, add it here. So the answer is 12 sides to the polygon. Okay, moving on to question 7. Question 7. On the grid above, reflect the shape A in the line x equals 1. X equals 1. Can you show me any places on that graph where x is minus 1? It's not 1. There it's minus 1. But also here. Think of your coordinates. Also here. Also down here. So what you actually get for all the points where x is minus 1 is this straight line. Okay? That is actually the line x equals minus 1. That's going to be our mirror line. Okay? We want to reflect the shape. So it's 2 away from a mirror. It's going to be the same distance away. Okay? And this point is 1, 2, 3 more, 1, 2, 3, and this point here. Actually, what happens is it goes to a point like that. You just have to draw the mirror image, okay? Reflect shape A, done. Next question. Describe fully the single transformation that will map shape P onto shape Q. So we're starting on P and we're going to Q. Can you see that it's not turned around or anything like that? It's just been moved. When you move it, it's called a translation. Okay? We want to know how many across and how many up, or in this case down, so it's going to be a negative. Okay? Now positive is this way. If we move it back, it's going to be a negative again. So 1, if you're doing this in your exam, just think of a point, by the way. So 1, 2, 3, 4, 5, 6 across. Okay? And we said it's a minus, it's minus 6, and 1 down. So minus 1. Let me show you how you do that in your exam with a point. 1, 2, 3, 4, 5, 6, 1. Okay? Done. You can check it with another point if you want. It'll give you the same answer with every point, any possible point on the shape. Moving on. Question 8. Sophie wants to find out the amount of time people exercise. She will use a questionnaire. Design a suitable questionnaire for Sophie to use. Include some response boxes. So, let's get to the chase. How much time should we say to the nearest hour? To the nearest hour. To keep things simple for people. They can make their own choice. Do you spend exercising? Now that's not very clear. They might think, well, is that my whole life, or is that this week or today? So we need a time frame. How much time do you spend to nearest hour? How much time to nearest hour do you spending, sorry, terrible English there. We still want to get our English right. How much time do you spend exercising per week? Okay, it's quite tricky to talk and write sometimes. So we need some response boxes. Let's say no hours. Let's say 1 to 3 hours. Do not put a 3, don't overlap. 4 to 5. 6 to, I don't know, 8. Be nice if these are actually consistent. 4 to 6, 7 to 9. And let's say 10 or more. Okay, covers all the bases. Sophie asked the people at her swimming pool to complete the survey. This might not be suitable. Give a reason why not. Okay, so they're asking them how much time they spend exercising. It is biased. They are already at a swimming pool. So probably exercise. And what you can say for this is not a fair sample. Okay. Moving on. Question 9. The nth term of a number sequence is given by 3n plus 1. Work out the first two terms of a number sequence. So all you do is you put the term that you're up to, do 3 times it and add 1. So for the first one, first term, this number is 1. So it's 3 times 1, add 1. The second one, this number is 2. So it's 3 times 2, add 1. So our first number is 3, add 1 is 4. Our second number is 3 times 2 is 6, add 1, 7. Part B. Here are the first 4 terms of another number sequence. Find in terms of n an expression for the nth term of this number sequence. Right, what's it going up by each time? It's going up by 4. Okay, 4, 4 each time. We're adding 4. So that means that the trick is you put 4n. And the next trick to get the other number is going to be the same kind of form as this. As you hop backwards, you go back 4, and that takes you to -3. Okay, so that's your answer, 4n minus 3. Question 10. Diagram shows a cross-section of a solid prism. So it's being quite cunning here. It's not showing you what the shape looks like. A prism, you get a shape and you extend it. Okay, the length of a prism is 2 meters. So let's draw this on ourselves, because we know what a prism is, don't we? Okay, so that's what a prism is, and its length is 2 meters. Now everything else is in centimeters, so let's say 2 meters, 200 centimeters, 100 centimeters in 1 meter. The prism is made from metal. Density of a metal is 8 grams per, very important word, each centimeter cubed. So let's first of all find the volume. So for the volume, you want the cross-sectional area. We can get this by splitting our shape up into 2 rectangles, but let's just think 2D for now, because I made it 3D. So this is our cross-sectional area. I'm going to split it up into 2 rectangles. So this is 2 across and 7 up. That can be our first rectangle. 2 times 7, that area is 14. Our next rectangle is here. We know how far up it goes. It goes up by 2. We don't yet know how far across. We know the whole way across is 7. Okay, the whole way is 7. Across here is 2, so that means you need an extra 5. So that's 5. So the area is 5 times 2. 2 times 5, 10. So the cross-sectional area is going to be 14 add 10, which is 24. Now we want to make it into a volume by timesing across 200 slices. Okay, so volume equals 24 times by 200. Double 24 is 48, and you can add on your 2 zeros. Okay, centimeter cubed. For each centimeter cubed, per centimeter cubed, there's 8 grams. Okay, and we want to work out the mass. So that's how dense it is, how much mass is crammed into each bit of space. Okay, work out the mass of a prism, so we want to times that by 8. Okay, this is quite tricky because it's a non-calculator paper, so what I would do is I would think, well, I can times by 10 by adding another 0 in there. 4, 8, 1, 2, 3 zeros now. I can double, because I can double 48. So that's going to give me 1696. But do not forget about these 2 zeros here. So I'm now going to do the 10 times it, take away the 2 times it, to get the 8 times it. Okay, so it's a subtraction. We need to borrow from next door to get 10, 0, 0, 4. We need to borrow from next door again to get 17, take away 9, 3, 8, 4, 0. It's a mass, so it's going to be grams. Okay. Clear ink. Moving on, question 11. Peter, Tarish and Ben share £54. Ben gets 3 times as much as Peter. So let's do a little diagram. P, T, B. They've all got different first letters to their names, and they've got 54 quid to share. So Tarish gets 3 times as much as Peter. Ben gets twice as much as Tarish. So let's say that Peter's getting a quid. That means that Tarish is going to get 3 times as much, £3, and Ben gets twice as much as Tarish, £6. So if they had to share £10, things would be nice and simple, because Pete would get 1, Tarish would get 3, Ben would get 6. Now, this is a ratio question because this is what all ratios mean. It tells you how to share things out, okay? But you're not always going to have £10. This instance, we've got £54. So you have to figure out how many £10 go into 54, and the answer is 5.4, okay? So it's 5.4 lots of each of these. Okay, so we're just going to do times 5.4. You'll see how nicely it all works out. So Peter is going to get £5.40. Tarish is going to get, how much money does Ben get? Let's cut to chase then. We don't actually need Tarish. 6 times 5.4. So it's going to be tricky calculation for you to do there. Well, 6 lots of £5 is going to be 30 quid. And 6 lots of 40p is going to be, times by 5 is going to be £2. Add on another 40, £2.40. So that means that Ben is going to get £32.40. If you did carry on and work all these out, what you would find is that each of them gets, they all add up to £54. But I'm trying to do a quick paper here, so I'll leave that for you to do. Question 12, we've got some laws of indices to work on. It's the same letter to a power. So this is W times itself 6 times W times itself 4 times. So guess what? We've got W times itself 10 times. You add the 6 and the 4. Okay. Here, when we're dividing, we can take away the 3 from the 8 because we divide by H times itself 3 times to get H to the 5. Part B, we have to simplify this. So you can think of 12 and 3 as the normal numbers, and the rest of the algebra might be cancelling as well. Okay, so what you've actually got is 12 and 3 cancelling normal as a normal fraction. So you can cancel that down only because this is all multiplied to 4 on the top. Here you've got x on the top and you've got x times x down here. So the x is going to go from the top and you're only going to be left with 1x on the bottom down below. Here you've got y cubed, divide by y cubed, so it's going to disappear. So that answer is just 4 over x. Moving on. Question 13. The table shows some information about the weights in kilograms of 100 boxes. Draw a frequency polygon to show this information. With a frequency polygon, what you do is you go to the middle, okay, of each group, the midpoint, and you plot the frequency against the middle of the thing. So, middle of 0 and 4 is 2. Middle of 4 and 8 is 6. Middle of 8 and 12 is 10. Middle of 12 and 16 is 14. Middle of 16 and 20 is 18. And you're just going to plot these values, and I'll show you how you do it as a frequency polygon. So what you do is we plot these as coordinates, 2 across 10 up here, 6, 17 is going to be here. Just think of your scale, this is 17.5, so this is 17. 10, 28, we're just plotting them as coordinates, here's 10. 28 is going to be up here, there, okay, because each 2 is one jump. 18 and 20, we've done 14, 25, sorry, not yet, trying to rush too much here. 14, 25, 14 across, 25 up, there. 18, 20, 18 across, 20 up is going to be here. And what a frequency polygon does is you get your ruler and you just join the dots. probably the only time in maths that you can join the dots, and that's now the frequency polygon. Do you need to do anything else on that? What else does the question say? That's it. Clear ink. Question 14, construction question. Use a ruler and a compass to construct an angle 30 degrees at P. So this is where we want our angle. Show all your construction lines. Do not use a rubber unless you make a mistake. Leave your working outlines on. Right, I do not have a ruler and a compass in my hand. I'm going to try and show you and explain how to do this question. First thing you do is let's make up a ruler here. You get your ruler, okay, and you measure the length of this, and you set your compass. Let's imagine a big compass as well, okay. You set your compass that wide, okay. So once you've got your compass set to that width, what you're going to do is you're going to stick the spiky end in here, and you're going to turn it around. So it's going to stay at P, and it's going to spin around like that. Okay? At least a little bit like that. It'd be in a circle. Okay, now you turn your compass around, and you stick it, the sharp bit, in here. Okay? And you spin it around again, backwards, so you get a curved line like that. Now, because the compass has got all the lines the same, what you've actually just made, if you join this up, is an equilateral triangle. Okay, 60, 60, 60. How do we know? Because all the lengths are the same, because of how you've used your compass. So it's an equilateral triangle, so all the angles are the same. So now, if we want 30, we just need to cut this 60 angle in half. So you might know the steps to do this. You get your compass, you stick it in P to any length, you curve it around, make a mark here, curve it around, make a mark here, okay? Then you stick your metal bit in here now, and you curve it around there. Then you stick your metal bit in here, you curve it around there. I hope that's made some sense. Okay, now you draw a line through the center of this point and through your original angle P, and that would give you an angle here 30 degrees, which you can label, and that's the question done. Moving on to question 15. Expand these brackets, so you've got x times x plus 2. X times x is x squared, x times 2 is 2x, and in the middle you've got a plus. Expand and simplify, this is the banana method. I've got a video on this. Okay, so x times x is x squared, x times minus 4, minus 4x, 3 times x, 3x, 3 times minus 4, minus 12. Put these two together. Now don't forget this minus sign here, it's very important. So minus 4 plus 3. So you're on minus 4 on your number line. You add 3 on, takes you to minus 1. So that is just minus 1 lots of x, or just minus x. That's your answer. Okay, factorise completely. So now we're going back into brackets. Okay, look at your numbers. What is the biggest times table they're both in? The answer is 2. And is there anything else that's common? Well, look, here you've got y squared, which is y times y. And here you've got y. So you can take a y out. What do you have to times 2y by to get 2y squared? You need another y. What do you have to times 2y by to get 4y? Just 2. And in the middle is a negative. 2y times y minus 2. Factorise completely. I like this one. You can think of this one as x squared plus 0x minus 9. Or if you like learning rules, you can think of the difference of 2 squares, which tells you what it's going to go to. This way will work too. You want two numbers to add to 0, so they must be the same, times to 9. X plus 3, x minus 3. You can just learn this as a rule, which is why it's only 1 mark. And all you do is square root the 9 and put a plus and a minus. Okay. Question 16, fraction division. So when we divide in fractions, we can times it, change it to times, and flip second fraction. That's because times and divide are reciprocals of each other. So we can flip the second fraction, make it multiply. When you multiply, just multiply across the top. 2 times 6 is 12, 3 times 5 is 15. Simplest form, there in a common times table, you can divide them both by 3 to give you 4 over 5 as your answer. 3 marks, not bad, hey? Right, you've got, I always think of these as cakes. You've got 2 full cakes and a third of a cake. There's a third. And you're taking away 1 whole cake and 2/5 of a cake. So someone would cut the cake into fifths, which is quite tricky to do. And you've got 2 of them. So that's what you're taking away. Think of your whole cakes first. Your whole cakes are your numbers, 2 and 1. So you can do 2 minus 1, which means you're left with 1 whole cake. Now let's do the fractions. So the fraction was 1/3, take away 2/5. Now you can do a smiley face method here, which I also have a video on. 1 times 5 is 5, 2 times 3 is 6, 3 times 5 is 15, and it's a take away. Okay, so it's going to be, don't worry if you get a negative fraction, by the way. 5 take away 6 is a minus 1 over 15. So now you're putting together this 1 that you had, this 1 full cake, and the minus 1 over 15 that you owe. Okay, 1 whole, imagine you've got a whole and you cut it into 15 pieces. You've got all the pieces, so it's 15 out of 15. So 15 out of 15, take away 1 out of 15. They're the same common denominator, so you just take away, the answer is 14 over 15. For another 3 marks. Okay, question 17. We've got a triangle diagram. In the triangle ABC is a triangle. Angle ACB is 90, it's shown on the diagram. P lies on the line AB, we can see that. CB is perpendicular, we can see that because we've got a right angle here, and hence, because it's a straight line, a right angle here. Prove that the angles of a triangle APC are the same as the angles in the triangle CPD. So APC is this triangle, okay, with 90 degrees here, and CPB is this triangle here. So what we're trying to show is the angles are the same. You can see from the diagram we want to know these angles being the same and these angles being the same. So let's get on with thinking about how we can do that. Okay. So this angle here we want to be the same as this angle here, and these two the same. So we know, let's label these up. I don't want to use all 3 letters every time. A, B, C, D, labeled up. So angles in a triangle equal 180 degrees, or add up to 180 degrees. Therefore, A plus B equals 90 degrees. That's because we've already got 90 here. Okay. And we also know from angles in the other triangle that C plus D equals 90 degrees. We also know that these two add up to 90. So B plus D equals 90 degrees. That's because they're on a right angle. So what we're going to do now is we're going to use this information, okay, and we're going to substitute in B plus D equals 90, but we need to rearrange to get B equals. So we're going to take D from both sides of here. So B equals 90 minus D. Okay, and now we can substitute in this B for this. Okay, so if we take this top equation and this one, we get that A plus 90 minus D equals 90. Take away 90 from both sides, plus D to both sides, so A equals D. So we've shown that these two angles are the same, A and D. What else do we need to show? We need to show that B and C are the same here. Okay, so you can see from that that they're the same, can't you? Because if you want to do the algebra way, you can say, well, 90 equals 90, so C plus D equals B plus D. Take B from both sides, so we also get that B equals C. So they're the same angles in both. Okay, I have tried to rush through that a bit, and it always helps in a proof if you write down with your working out instead of all over the place, which is why it gives you quite a lot of space. Blank page, question 18. This table shows information about the time in minutes it takes to show each of 120 films. Okay, write down the modal class interval. Modal is the most common. Okay, so the most common class interval is the one with the most people in, because the frequency is the people. Okay, so 34 is the highest number, so the modal class is 90 to 100. Okay, so modal has got the most people in. Complete the cumulative frequency table. So what I'm going to do is I'm going to draw it on the side, because I think when we scroll down we're going to have to draw it on a diagram. So all you're doing is you're thinking we're adding up the frequencies each time. So 70 to 80, I don't mean take away, it's just I'm saving space. 90, 100, 100, 110, 110, 120, 120, 130, and that's it. Right, cumulative, adding up each time. So I would be writing this here in the exam, but you'll see why I'm not in a second. So we start on 4, we then add another 12 people, so we've got 16. We then add another 34 people, so we've got 50. We then add another 32 people, so we've got 82. We then add another 26 people. I'm saying people, what am I actually on about? DVDs or something? You know what I mean. So 108, add another 12 people. Bingo, it adds up to 120, which is what the total amount should be. So that's good. Let's erase this working out. And I don't think we're going to need that. That would have got us just 1 mark, because all you're doing is adding up numbers. And now comes the fun of the cumulative frequency diagram. Okay, so we need to fill this in, draw cumulative frequency diagram for the information. So starting off at 70, by the time we've got to 80, we've added up 4. So by the time we get to 80, we're on 4. Work out your scale. Half of 20 is 10. We're going up 2 at a time, so 2, 4, etc. So by the time you're at 80, you've added up 4. By the time you're at 90, you've added up 16. We've already added up these values, so it's all good. Okay. By the time you're at 100, you're on 50 people. I'm saying people, I can't remember what we're even talking about. By the time you're on 110, you're on 82. Okay, so remember your scale. By the time you're on 120, you're on 108. It should never go back down here because of what we just did. We're adding on each time. By the time you're on 130, we're on 120. So 130, we're on 120. Right, now you've got to be very careful, and you've got to draw nice smooth S that goes through all your points. I wouldn't be too happy with that in the exam, because that bit in the middle wasn't quite going through the points properly. So let's keep the red one, delete the green one. I prefer that one. Okay, so it wants to go through all your points. It wants to be a nice, even that's not brilliant, nice smooth curve, because I've missed this bottom one. Oh well, you get the idea. Use your graph to estimate the median. So median is middle value. We've added up 120 things, so halfway in the middle is 60. Let's read across at 60, go down. Sorry about the lack of ruler. In the middle of this is 105. 1, 2, 3, 4, 5. So it's 103 minutes. It's the median. Okay. The dot on my eye already done for me. How efficient is that? Moving on, solve the simultaneous equations, question 19. It's a little shortcut here. I know I've taught you with step X, but actually we can think we want 4 to be the same. So let's just times this second one by 2. Keep the top one the same. Step X would still work, but this is a shortcut for you. Times each thing by 2, 2x, times by 2, minus 6y, times by 2, 38. So you now do your rectangle step. There's invisible pluses. You stop. You think it's the same sign, so it's going to be a takeaway. You get 0 under your rectangle. You've got 1y, and you minus 6. So it's going to be 1 plus 6. 2 minuses make a plus. 7y. And you do 10. Take away 38, so we go into the negatives. Minus 28. Divide by 7, both sides of the equation. 28 divided by 7, if you know your times table is 4, it's a negative in front, so it's negative 4. Now we pick our easiest equation. In this case, I reckon it's 4x plus y equals 10. And we substitute in that we know y is 4. Okay, so we know that is minus 4, not 4. So our equation changes to 4x minus 4 equals 10. We want to get x on its own, add 4 to both sides of the equation. We get 4x equals 14. Do not be dismayed that you might get a decimal, that's okay, as long as it's not too horrible. Divide by 4, divide by 4. Trick to divide by 4 is going to be half it again. Okay, so you're going to be starting with 14, half of 14 is 7, half of 7 is 3.5. So that is your answer, that y equals minus 4, x equals 3.5 for 3 marks. Clear the ink. Question 20. Box plots show information about the points scored by students in spelling competition. Compare the distributions of the boys' scores and the girls' scores. When you compare box plots, you want to talk about how it's spread out, measure of spread, and an average, which is usually the middle, the median. Okay, so they have the same median, have the same middle value. These are the middle values. Same median, and we might as well show off, say we know what it is. It's 80. What else? How spread out it is. So you can see that the range for the interquartile range and the actual range is bigger for the boys than the girls. Okay, so what you're going to say is the IQR is bigger than for boys and girls, more spread out. Okay, probably be better if you put numbers in as well, just to show what you're on about those interquartile ranges. Question 21. L is a line. Work out the gradient of the line L. And we've got some other stuff going on. So the gradient. Gradient, always think change in y or change in x. That's it as a formula. But what I think is Gradient tells you if you go across 1 for x, how far up or how far down is it going, and that's your gradient. Okay, and if you think you've got a big number here, well, you get a steep line. That's why gradient relates to steepness. If you've got going down, it's negative. Anyway, without further ado, let's apply our formula. So it's going to be a nice triangle that we draw in. So we get the change in y as it's gone 1 up, or 1 down, -1. And the change in x is it's gone from 0 to 2. Okay, so the gradient is going to be a change in y from a formula over the change in x minus a half. Okay, you can see it's going down. Part B, we're probably going to use the diagram again. Another line, line M, is parallel to line L and passes through a point 6,2. Through point 6,2, let me make a note of that. Okay, parallel. So, if it's parallel, it means it's the same gradient. Okay, so it's somewhere around. We're not quite sure where. Well, we are sure where because it goes through a point 6,2. 6 across, 2 up. So let's put that point on. So, bingo, we know exactly where it is. Okay, it's there. And it asks us to work out the equation. If you're really good visually, you could do the equation like this. Or you could use the formula of y minus y1 equals mx minus x1. I said I was trying to do this exam quickly, so I'm going to do the quickest way. Quickest way, you think, well, 2 across, 1 up, 2 across, 1 up, 2 across, 1 up, 2 across, 1 up. It goes through the point 5. We're going to be giving it in the form y equals mx plus c, where m is the gradient and c is the y-intercept, which is where it crosses the y-axis, which, guess what, is what we just labelled on as 5. M, we've already done that, minus a half. So the equation for part B is y equals minus a half x plus 5. Okay, let's just check there's nothing else to do. Nope, 2 marks that one. Question 22. Find the value of 27 to the power of minus 2 over 3. This is more like a Core 1 A-level question. Negative in the power means you do 1 over the exact same thing we've got here, but without the negative. Okay, so 27 2 over 3. Okay, so what does this 2 over 3 mean? Well, it means that you can either do, because of your power laws, when you do to a power and to another power, you can either do the 3 first and then the 2, like so, or so that the third and the 2 times to give 2/3, or you could do that the other way around, third. Now, power of a third to any number, power of the third means the cubed root. It means what times this by itself 3 times to get your value. So do you want to think about what times this by itself 3 times to give 27, or do you want to do 27 squared? I don't want to do 27 times 27 because I know that 3 times 3 times 3 gives you 27. So that is this one. Okay, so 1 over 27, just recapping what we've done, squared. The cubed root of 27 this is. Okay, cubed root of 27 is 3, just a different way to write it. 1 over 3 squared is 1 over 9. That's your answer. Okay, like I say, it's more like an A-level question, it's quite a tricky one. Third question, given that 8 minus root 18 over root 2 can be written like this, find the values of a and b. Okay, this is like your answer, so just ignore it and just work on this. can you see there's no divide by anything here? So we want to get rid of this root 2. If you've done surds, I have actually got a surds video as well. You can see that we want to multiply by root 2 over root 2. The top needs to be kept together, so you got root 2 times 8 minus root 18. Root 2 times root 2 is 2. Let's multiply in here. Root 2 times root 8, we'll leave it as 8 root 2 for now. Root 2 root 18, all over 2. Now, running out of space, so let's do it here. Square root of 2 times 18 times root 18, same as the square root of 2 times 18. 2 times 18 is 36, so this is the same as the square root of 36, which means what times this by itself to get 36. If you know your times tables, again, it's very, very useful to know that 6 times 6 is 36. Okay, right, this divide by 2, you're doing it to everything, so you can divide the first thing by 2, the second thing by 2, so you get 4 root 2 minus 3, or if you write this the other way around, minus 3 plus 4 root 2. Either way, we can see how they correspond to each other. A is a number on its own, minus 3, and B is the number in front of the square root 2, which is 4. So we just write that as our final answer. A equals minus 3 and B equals 4. Okay, let's clear the ink. Question 23. Make K the subject of a formula. This is more tricky because K appears more than once. To make it the subject of a formula, it has to be K equals something. It's not good enough to have K on this side. I'm afraid, sorry, not allowed. So let's see what we do. Right, so we've got T equals K over K minus 2. We don't like this thing here, so we're going to times up by it. Times up by the whole thing on both sides of the equation. So on the left-hand side, we've got a T from before, and we're now timesing up by K minus 2. And on the right-hand side, we've just got K left now. We multiply in, using our algebra, KT minus 2T equals K. We now try and get our K's all together, so we take away this K onto this side. So we get KT minus K. We've still got a minus 2T we're not too keen on. There's nothing left from there. You had K, you took away K. Okay, let's first of all, just said K there, that was good, wasn't it? Okay, so we take our 2T to the other side by adding it to both sides of the equation. Now here's the clever part. You've got K separate. Guess what? If we factorize, you've got K on its own, which is a really cool trick. Some people at A level get stuck on this. What you need in the bracket is T minus 1. So when you times in, you're okay. Now we just want K, so we want to divide by T minus 1. So it's 2T over T minus 1. Job done. Are there any more questions? Yeah, there are. How many are there? Oh, we're still going for a while yet. Okay. Question 24. The incomplete table and histograms give some information about heights of some sunflowers. Okay. What we need to do is we need to complete the histogram, complete the table. Okay, for 4 marks in total. So can we get it all on one screen? Just about. Okay, so this is frequency. Okay, I am doing a video on histograms as well, so if that's not already up, it will be up very soon. What you have with a histogram is the area represents how many people you have. Okay, so that means that when you times these two lengths, that gives you how many people. And what we have across the bottom is the width, and we have something called frequency density. So the width is just literally how wide each of your bars are going to be. Now, if you're going from 100 to 30, 100 to 130, that's 30 wide, isn't it? Okay, so 30 wide, this is a width, 20 wide from 130 to 150, 10 wide, 20 wide, and 30 wide. Okay, now we have to times that by something called frequency density to get the answer of frequency. So here our frequency density is 1. Okay, here it is 2. Here it's going to be a dodgy decimal, so let's leave that for now. Okay, so if we've just said that the frequency density is 1, and this is frequency density going up, we know the scale of the side now. 1, 2, 3, 4, 5, 6, 7, 8, which is very useful. Okay, and we can figure out the rest of the stuff by looking at the scale. So it's going up in 0.2, so that's 4.2 for this category. Okay, for the frequency density. Not very nice numbers, I've got to say. For our 150 to our 160, that is going to be nicer number 6, so we'll work that out straight away. For frequency for the area, that's representing 60 people. Okay, there's one more to do, 20 times 4.2. It's not actually that bad because it's double it and then add the, well, times by 10, 84. Okay, which is good because if we're talking about people, we don't want any fractions, we want whole people. And so there's one missing number. 30 times by something, which is going to be this mystery number, gives you 18. So don't worry about the frequency density being a decimal. That's 18, not 1.8. That's just a multiplier. So we need to divide by 30 to get this question mark. So 18 divided by 3 is going to be 6 lots of 18. 6 lots of 3 gives you 18. And it's divided by 30. So you're dividing by a bigger number. So it's going to go smaller to 0.6. Okay, so that's 0.6. We completed the table. Let's finish off the histogram. So we're going to have from 160 to 180. 160 to 180, we need to go up to, that's what frequency density stands for. You would use a ruler and yours would be very, very neat, not like mine. Okay, for the last one we want to go up 0.6 from 180 to 210. So let's try to trick you by going up to 220, don't fall for it. And we just go up to 0.6. Each one was 0.2, remember, so that is our up to 0.6. That's our histogram done and our table done for our 4 marks. And peeking ahead, it looks like we're going to need some formulas. Let's just get up a formula page. The information that we need is the surface area of the sphere is 4 pi r squared, and the curved surface area of the cone is going to be pi rl. So 4 pi r squared, pi rl. Okay, so this is to do with the cone, this is curved, this is to do with the sphere, but it's a whole sphere. And we've got a semisphere, half a sphere. Okay, so let's read the question. We've got a solid cone and a hemisphere. The cone has a base radius x and a height of h. Hemisphere has a base of radius x. Surface area of the cone is equal to the surface area of the hemisphere. Okay, so by surface area we're talking about wrapping up the shape. How much paper do we need effectively to wrap up the shape? And do not forget about these circles on the bottom. Okay, you're going to need paper for those as well. But the cool thing is that because that's in both, we can think, well, they're already equal, so we don't need to worry about that. And we can just worry about the curved surface area of the cone, and we can just worry about the curved surface area of the sphere. Okay, so for the cone, we have a formula pi times r times L. Okay, now L is the missing value here, okay, which we do not yet know. But we do know some Pythagoras that x squared plus h squared equals L squared. When this is a right angle, which it is, x squared plus h squared equals L squared. Okay, an expression for h in terms of x. Are we going about this the right way? I'm not sure yet. Let's look at this for a sec. So here we know for a full sphere, if we want half a sphere, we can just half it. So divided by 2 pi r squared. And what we know is we know that our radius is x. Okay, r equals x. So 2 pi x squared. And that is equal to pi r L. Now r we've just talked about being x. Okay, so we can substitute that in as x. We can divide both sides of this equation by x and cancel that 2 with that x. So pi L equals 2 pi x. We want an expression for h in terms of x. So L, be nice if it's L squared, but it's not, is it? Expression for L in terms of x. I'm just wondering if to square both sides here or not. We can also divide both sides by pi, so L equals 2x. Okay, and now let's square both sides. L squared, and when I say square both sides, square the whole thing, 4x squared. So we can now substitute this in for L, so the same thing. So you get x squared plus h squared equals 4x squared. And we want an expression for h, remember. So take away x squared, h equals 3x squared. Now you can square root. So it's going to be, we do not need to worry about negatives because it's all in lengths. So h is the square root of 3x squared. Use your surd rules. Root 3x. Tricky question there, to be fair. And how many marks do you get for the pleasure? 4 marks. Question 26. Wow, this paper just keeps on going. Okay. So OAB is a triangle. O to A is 2A. O to B is 3B. Okay. So if that's halfway, you can imagine this is your vector A. You have it twice. Okay. Same for B, but you're split into 3. Find AB in terms of A and B. Okay, so from A to B, we can get that by going backwards along here and then up here. So backwards along 2A is minus 2A, and then along 3B, 3B. P is a point on AB such that the ratio of AP to PB is 2 to 3. Okay, so AP to PB is 2 to 3. Okay, so you split it up 2, 3. Okay, so that means that all the way there's 5 pieces, so that's 2 out of the 5, that's 3 out of the 5, if that makes sense. Show OP is parallel to vector A plus B. So O to P is here. Okay, so that is a vector that we're talking about. So to get from O to P, let's go 2A. To get to here, and then we need to go 2/5 of the way along the vector AB. Okay. We already know what the vector AB is. It's here. So we can do a bit of algebra. 2A plus 2/5 minus 2A plus 3B. Let's take our algebra up here to give us some more space. So we're going to expand out the brackets. 2/5 times by minus 2A plus 3B. You might have been inclined to swap those two numbers around, which would have been fine. So you get 2A plus 2 over 5 times 2A is 4 over 5A, but think of a minus, so there's a negative there. Okay. Now that one's done. 2 over 5 times 3 is 6 over 5, and it's lots of B, and it's just a plus there. Right, so 2A, 2 can be thought of as 10 divided by 5. So we're going to write, instead of 2 lots of A, 10 over 5 lots of A, because that will help us with it being a non-calculator paper. Do 10 over 5 minus 4 over 5, 6 over 5A plus 6 over 5B, which equals 6 over 5A plus B, which means that it's parallel, okay, because it's a multiple of the other. Parallel to AB. Okay, because it's just a multiplier times A plus B. Clear ink. Question 727. We've got a nice bit of algebra and an equation to solve. X over 2 minus 2x plus 1 equals 1. What you want to think when you're solving an equation is it's not nice to have things down here. So this is kind of called cross multiply, but effectively what we're going to do is we're going to times everything by 2. And because there's 3 terms, that means literally everything. And we're going to times everything by x plus 1. So we can do this in 2 steps, so you can hopefully see what's going on. When we times it by 2, we get x minus, this becomes a 4. Times everything by 2, that becomes 2. Right, so times it by x plus 1, x plus 1, minus 4, 2. Got to times this by the x plus 1 as well. Now expand these brackets, we get x squared plus x. So minus 4 still here, you can't forget about that. Times up this single bracket, 2x plus 2. Right, this is going to be a quadratic to solve. So you've got x squared, we'll keep that positive, keep that on this side. Take away this 2x, so x minus 2x is minus x. Take away this 2 equals 0. Let's hope this factorizes. 2 numbers that multiply to make minus 6 and add to make minus 1. So we've got a difference of 1. The 2 numbers are going to be minus 3 plus 2. 2 brackets multiplying to make 0, which means this could be 0 or this could be 0. The first one is 0. You can get that by having x equals 3. The second one 0 by having x equals minus 2. 2 possible answers there. We have solved that equation. Some very tricky questions in that exam, but we've done it all now. I hope it was useful. I made a conscious effort to do this one as quick as I could, just for something new to do. Let me know if you like that method or not. And like and subscribe. Thank you for watching. Hope you achieve maths. Goodbye.